Okay, so
Come on, that's a good
we're
one.
taking on the solutions for the ninth
That was a good
free
one.
response question set.
All right.
The first
Thank
one here
you.
gives
No,
you
I liked it. I liked it.
a
All right.
situation
So the
where
way
you have
you guys are just
collecting
letting me go.
of grass clippings, and
All
the
right.
amount of the grass
So here's
clippings
how this is going to
is
work, by
given
the
by a
way. This I
function
think is going to
A.
be
Um, so it wants the average rate of
hopefully going to be
change
helpful for you.
from 0 to 30.
Every
So
day at 2
average
o'clock,
rate of
you
change
will have from
is
2 to
always going to
2:30, you
be
will have a
the
lesson with
value
either
at
myself,
the one
Miss
endpoint
LaRuffo, or
minus the value at the
both of us.
other endpoint
So on Mondays and
divided by the
Wednesdays,
difference
you're
of
going to
the
do your math
endpoints.
lessons with me.
So
And what that's going to look
if you
like is
take
on
into the
Monday,
calculator,
we're going
A
to
of
do
30
lesson
is
1
approximately
of course
7 or
folder. On
0.78292.
Wednesdays, we're going to do lesson 2 in your course
A at
folder.
0
Okay? That way
has to
you
be
can do it all by yourself.
6.687.
Does that make
You
sense?
can kind of convince yourself of that
Okay. And
mathematically
so the videos that I'm putting out,
over
we're actually going to
30,
look at
right?
this together in
So
our
throwing that in
one-on-one
the
Monday and
calculator,
Wednesday.
that's
So that
approximately
way you
negative
can
point
take
0
notes on the video
or
like
negative
you would without me. But
0.196,
then we'll have
and
some
that's
time after
pounds
that to
per
maybe work
day
through some
is
of
the
those static
correct
problems
unit there.
together.
So let's look at part
And if you
B.
have any questions or if you got
Part
confused
B
in the video, you guys
literally is
have
something
to
you can
come
throw
with me
into the
and we'll work
calculator
together.
because you just need a prime
So
of
you have a
15.
choice.
The calculator will
If
do
you
that calculation
can,
for
you
you.
can print out the notes page.
So that's
That's
negative
in your course, or
0.163.
for no
That's
paper or
also
pencil
in pounds per day
and
because
take
that's an
notes
instantaneous
while the
rate of
video's
change of
going.
A.
Okay?
So this
Either
means
way
that
is fine.
at the
And then
time
so you don't
where
have
t is equal
to
to 15, and that's in
rush through and
days,
take the notes before you come with
the
me on Monday and Wednesdays. We
amount
can use this as our math time for the day.
of
You
grass
will know, if
clippings
you notice, but in your course folder, you have to do the
remaining
activities in order. So first you would have to do the objective,
is
then you
decreasing
would do the think about it. The think about it, you
at
actually have to submit an online response and
0.163
submit it, and
pounds
that will let you open up the
per
video and the
day.
notes page.
All right, so that's
That's
part
it.
A.
Then some people were
Part B,
kind of going right to the show
let's
what you know exit ticket
move
without doing
on
anything in
to
between,
part
and
C,
then
which is about an
that was how
average.
that
Right, so
sorted.
let's look at part C.
So
Find the
Friday, we're going to
time
do,
for which
now we're kind of moving
the
ahead.
amount of
We're going to
grass
do a health
clippings in the
lesson.
bin is equal
So
to
this
the
week and next week will
average
be a health
amount of grass
lesson.
clippings in the bin.
Does that make sense?
So we need
Any questions?
when
I know it's
is
a lot coming
A,
at you.
what time C
Did you see
are we
on your
equal to
course
the
page when you
average
schedule it at
value
the
of
bottom?
A, right?
Is that helpful?
So
Okay.
if you throw this into the
Also, the test
calculator,
specials
you
now
get
with your
approximately
teachers.
2.752635.
Well, it's a neat
So
thing
the
to
point at
actually be
which
on
A
with
of
your
C is equal to
teachers.
that, you can
Before it was
also
just the
find by
activities
an
you posted
intersection in the
and you did them
calculus
on
is
your
when
own,
C
but now you can
is
actually do those
approximately
quizzes with your teacher. So you guys have
12.414.
music today at 3
So
o'clock
that's
with Miss
part
Timmons and
C
Miss
of the problem.
Malone.
All
So
right,
you will use
so
their Google
part
Meet code,
D of the problem
which is
says when
on
t is
that
bigger
schedule. I'm
than
going to try to
30,
put everything
it's better
on
to
there.
use the approximation
Right here.
found at
Oh my gosh. She
30
was like,
and
I'm done
then
with this
to
meeting.
go
She's
from
she's
there.
talking too much.
So we want to know at what point will there be only half a
So
pound
I try
left
to put
of grass, and
everything
that's going to be
there
at
with the
some point
times and the
after
codes that
time
I
30.
had
So to make
so
that
that
linear
it's easier for
approximation,
you in one place to
I
go.
need the value
All
of
right.
A at
So
30, which we already
I
found
set
is
all of
approximately
that. If a question comes to mind, that should be
0.7927. We found
tough.
that in part A
You
of
are
the
more than welcome
problem.
to send me a message.
We need A prime
What
at
I'm teaching
30,
right now
which
is
you
I'm
can
going
do
to
with the
play
calculator.
the video
Gives you
for today, right? So you can take
0.005976.
notes with me
So
while we
L of
go, and then we'll
t
have some
is
time
going to be
afterwards to work on some
minus
of the triad
the
problems. So if you have a piece of paper
0.78297
and a pencil,
is equal to the
and the first
slope
thing that you need is you need to write your title of what this is all
times
about.
x,
So
or
write
t,
it in
I guess,
percent so that
minus
I can
30, right? T is the
kind
variable
of
there.
start to guide you a little bit.
Um, I
Now,
rewrote
I'll tell you
that
this: when I
so that I
present,
had
I
it
can't
as
see
y
you.
equals mx plus
So
b.
if you have a question, you'll need to kind of say, Mrs. Bean,
Well,
because
not
I don't see
mx
you
plus
raise your
b,
hand
but
very
m
quickly.
times
I haven't figured
something,
that
and then
feature
brought
out
the
yet, Miss.
constant over.
Okay. So can you see my screen?
Okay, so we want when is 0.5 equal to this?
Uh-oh, what's this? Oh, that's next week. Don't look. All right. The sneak peek. Yeah.
So
all right.
again, you can play an intersection with the calculator and get that t is 35.054. So there you go. That's the complete problem number 1. Let's look at problem number 2. Okay, so I'm looking at problem number 2 here. The first thing it asks me for, you have an f, and then g is the integral function of f. So first thing it asks me for here is g of 3, which means I need the integral from -3 to 3 of f of t dt. That's going to give me a big triangle with the area above the curve, and then a small triangle with the area below the curve, or below the x-axis. So this is 20 divided by 2 is 10. This is just going to be -1, makes that 9. So that's not so bad. Let's look at part B. Part B of the problem says what open intervals is what open intervals are both increasing and concave down. So in this problem, we want to know where we're both increasing and concave down. Okay, so we're increasing when g prime of x is greater than 0. So this is when f of x is going to be positive, right? So this is going to be on -5 to -3. And then from -3 to 2, I'm increasing. Then I want to look at when is g double prime bigger than 0. So that's when is f prime of 0. So that's when is f increasing. F is increasing on -5 to 3 and 0 to -4. So this is going to be, sorry, when f is decreasing. I'll get this backwards. This should be concave down. So this should be when f is decreasing. This is concave down. So now we're going to look at the overlap. It clearly overlaps here on -5 to 3. So it's both increasing and concave down on -5 to 3. And then if I look at the overlap here, it overlaps between 0 and 2. So there's 2 open intervals where I'm both increasing and concave down. So that's part B of the problem. Let's move on to part C. Okay, so we're looking at part C of the problem. I have in part C that h of x is equal to g of x over 5x. So the derivative of this is going to be low d high minus high d low over low squared. Okay, so we want this value at 3. So this is going to be 15 times g prime of 3 minus g of 3 times 5 over, this I think comes out as 225. All right, g prime of 3 is going to be f of 3. So f of 3 is -2. Okay, g of 3 is a known value because we got that in part A. So that's 9 times 5 over 225. So this is -30 plus 45 minus 45 over 225 gives me -75 over 225, which is -1/3. So that's part C of the problem. Let's move on to part D. Okay, looking at part D of the problem, We have a function p, which is defined as
What I would do is
f
draw this
of x
chart
squared
on
minus
the page
x.
so that you
And then we want to find the
show
slope of the tangent line. So that's the derivative of p at x equals negative 1. So the derivative of p
and I'm just gonna pause
is
it and so you have a chance to
this
copy it
times
back.
the derivative of the inside. And we want that at negative 1. So let's see. That's going to be 1 minus negative 1. So that's going to be f of prime of 2. And then this is negative 2 minus 1 is negative 3. F prime of 2 is the slope at 2. So if you look at that graph, that's going to be negative 2 times negative 3 is positive 6. And that's part D of the problem. So not so bad. All right, so let's talk about part C of the problem. This is when we're giving values in a table and have to draw some conclusions here. The values in the table are the velocity for a train A. So we need to find the average acceleration, which is, again, average rate of change for velocity. So the average acceleration is going to be the velocity at 8 minus the velocity at 2 over 8 minus 2, which is negative 120 minus 100 over 6 is negative 220 over 6, which is negative 110 over 3 meters per minute squared, right? It's meters per minute. Part B says, it just asks a straight up question. Does this data support that the velocity is going to have to be negative 100 meters per minute at some time between 5 and 8? Well, yes, because V8 of 8 is negative 120. That's less than negative 100. And VA of 5 is positive 40. So negative 100 is between these two things. So this is true by the intermediate value theorem. All right, so let's move on to part C. All right, so we're given that at time 2, A is 300 meters east of origin station. We want to know where it is at time 12, and we're going to use a trapezoidal approximation to figure that out. So fundamental theorem of calculus tells me that 2 to 12 of VA of t dt,
Do you find this to be a little bit easier than
sorry,
the customary units?
dt is equal to position of train A at time 12 minus the position of train A at time 2, where east is positive, right? So we know that the position at time 2 is 300 meters to the east of the station. So this means that the position at time 12 is going to be this integral plus 300, right? So now we get the trapezoidal rule. So we have 3 subdivisions in the trapezoidal rule. The first one runs from 100 to 40 with a width of 3. The second one runs from 40 to negative 120 with a width of 3. And the third one has heights on either end of negative 120 to negative 150 with a width of 4. And then we're going to add 300 to that. So this is like 140 divided by 2 is 70 times 3 is 210. Negative 80 divided by 2 is negative 40 times 3 is negative 120. Negative 270 times 2 is going to be negative 540. And then we have to add that 300. If you take the sum of that, I think you get negative 150, which means train A is 150 meters west of origin station at time t equals 12. Okay, so let's look at part D. Part D is a related rates problem. Okay, so just to get a little picture of this, you have one train that's positive as east. You have another train that's positive as north. And this is the distance. Let's make that a capital D. This is the distance between the two trains. So this is the positive east distance. This is the positive north distance. Okay, so at the moment that we're considering in this problem, d squared is equal to 300 squared plus 400 squared, which means that d is equal to 500. All right, so also using that Pythagorean theorem, right? So we know that d squared is the position of train A squared plus the position of train B squared. This in east units, this is in north units. So we need to work out the implicit differentiation here. 2d dd dt is 2pa times the velocity of A, because that's the derivative of the position, plus 2pb times the velocity of B. Okay, so at this time, we know that the distance is 500, so this is 2 times 500 dd dt. At this time, the position of A is 300, and we know that the velocity is 100, because we get that from the table. At this time, we know that the position north is 400, and that velocity, v of b at times 2, is negative 5 times 4, plus 60 times 2, plus 25, which works out to be 125. All right, so let's simplify a bit here. This is 1,000. This is 60,000. This is 100,000. So that's going to give me 1,000. dd dt is 160,000, which means that dd dt is 160, and that is a velocity, so that's meters per minute. All right, so that's all of problem 3. Let's look at problem 4. All right, so problem 4 is giving us this figure. And the first thing is just to find the area. That's not so bad. The area is going to be the integral from 0 to 1 of the top curve, which is x e to the x squared minus the bottom curve. So the way that I worked this was to see it as two separate integrals. I worked the second integral first because it's the easy one. So that's going to be just x squared from 0 to 1. That just happens to be 1. Alright, so whatever we're getting is our answer for this. We're just adding 1 to that. This is a U substitution. It should be the x's here. Oh, not there. There. Dx is du over 2x. So this is going to give the integral from 0 to 1. Oops. X e to the u du over 2x. 2x plus 1. The x's cancel. So I made this 1/2 the integral from 0 to 1. Mind you, I can keep the 0 to 1 here because 0 squared is 0 and 1 squared is 1. Okay, there is a change of variable there. Plus 1. 1/2 e to the u from 0 to 1 plus 1, which is, let's see, that's e plus 1 over 2 plus 1. Right, sorry, this is not plus 1, it's e minus 1 over 2, right? E minus 1 over 2, which is plus 1, and then, so we're adding 2 halves, so this is going to be e plus 1 over 2. All right, so that's the area under the curve to an exact value. Let's take a look at the volume of rotation, but this is an interesting one here. Okay, draw the picture, draw the picture, draw the picture. All right, so this is my axis. This is the curve x e to the x squared. All right, there we go. This line is -2x, and this is the line x equals 1. So if you think about this, throw the 1 in there, you get -2. So the line that we're revolving around here is this. This is y equals -2. Okay, so this is the outside radius, right? So how far is that? Well, if I think about that, that's 2 to there, and then this distance is dependent upon x, and that is x e to the x squared. So that's the outside radius. The inside radius is this. So this is a little tricky too here, right? So the inside radius, well, this whole thing is 2, and then this piece is 2x, right? So we're going to subtract 2x from that, and we're squaring that, and we're squaring this. We're accumulating those radii from 0 to 1. We're multiplying it by pi. We're putting a dx on there, and there is my integral without any further ado. Okay, so let's take a look at part C. Okay, again, draw the picture, draw the picture, draw the picture. All right, so this is x e to the x squared. This is -2x. This is x equals 1. All right, we want the perimeter. This here, not too bad to figure out. This is down 2 over 1, right? So if I call that like d, d is squared is going to equal 2 squared plus 1 squared, which means d squared is 5, which means that d is the square root of 5. So that length is the square root of 5. All right, so let's play with this here. All right, so at 1, this y value is -2. This y value is 1 times e to the first, so this is e. So that total distance for the yellow, so we'll call it the yellow distance, is going to be, well, e minus -2, which is e plus 2. So now what we've got to find is the length of this curve, and we can do that using an arc length formula. So to find the length of that curve, we're taking the integral from 0 to 1. We need the derivative of this, right? So if y is x e to the x squared, dy dx is first times the derivative of the second plus the derivative of the first times the second. So this is e to the x squared times 2x squared minus 1. So we're going to take the square root, because this is an arc length, 1 plus e to the x squared times 2x, this is plus 1, right? And then we're going to take this whole thing and we're going to square that. And then we tack on the square root of 5. And we tack on e plus 2. And this is the whole perimeter. That ugly integral plus the square root of 5 plus e plus 2. And we're done with problem. All right. Problem 5 is little tidbits of Taylor formulas that we can use. They give me the general rule. If I follow the general rule, I can find the first couple terms of f. F becomes 2 times x minus 1 when I put 1 into the general rule, minus 2 times x minus 1 squared when I put in 2, plus 8/3 times x minus 1 cubed when I put in 3. And then I have the general rule, right? It's given to me, 2 to the n over n times x minus 1 to the nth. All right, so f prime is going to be the derivative of these things. That's 2. This is minus 4x minus 1. This is going to be plus 8x minus 1 cubed. And getting the general rule, that constant term does not change. The n's cancel, giving me 2 to the n, x minus 1 to the n minus 1. All right, so that's part A of the problem. Part B says that is a geometric series. So if you think about this, the first term of that geometric series is 2. Each time I'm multiplying by negative 2 times x minus 1 to the n minus 1. So in the interval of convergence, this is going to be 2 over 1 plus 2 to the x minus 1, which becomes 2 over 2x minus 1. All right. So it says you can use this to find f. So this is going to be f prime on the interval of convergence. Note, if you take f of 1, because this is centered at 1, you get 0. That's really useful, because now I can take the antiderivative. F is going to be the antiderivative of 2 over 2x minus 1 dx, which is the natural log, 2 times the natural log of the absolute value of 2x minus 1 plus c. But f is 0 when x is 1. So if I make this 1, I get the natural log of 1. Well, the natural log of 1 is 0, so c has to be 0. So f has to be 2 times the natural log of 2x minus 1, and I'm done. All right, so that's the whole problem set. Hopefully this was helpful. Again, join the drop-in if you have questions. Let me know where I can be helpful. Thank you.